Yeah, thanks for the intro. Hi, everyone. So our team at Media Lab is working on Dialogic core reading interaction to help improve parent-to-child conversational turn takes. And our team consists of our PhD student, Huili Chen, our postdoc, Sharifa, and Cynthia and I at Media Lab. So if we really think about it, at a very young age, before reading age, if we think about it, like no one starts to like learn things by reading and writing, right? So everyone starts to learn things by socially interacting with others, building relationships. So it's like a highly social event that happen to foster young children's learning. And that's where we got the motivation of using social AI agents in the picture of intelligent Turing system. And what further motivated our work was John's group's work on how the conversational turn takes between the child and the people around the child is like the most significant factor in their language development, unlike previous research is showing that it depends on the exposure of how many words that children are exposed to, right? So MITili first supported this work in the collection of parent-to-child conversation data set while they are doing story reading together. And from then on, we actually came a long way using that data set to develop like new algorithms, but also then to develop the triadic interaction involving the agent to support the parent and child's interaction during story time. And eventually we want to then develop a personalized agent that can support the most beneficial interaction between specific parent and child pair, and then even analyzing and tracking the effect of the agent-mediated interaction in the parent and child's like everyday context and how their dialogue and conversation changes. So with that being said, I'll like dissect our milestones. So first, we started with the MITili seed grant to collect data sets on parent and children having story time together. And during that time, with that data set, we analyzed, depending on their self-reported like demographics and also like parenting style and parenting stress scale and child temperament scale, like what correlations we could find to like those survey data to how they actually engage with each other in the story time. And using that data set, we have developed, for example, affect prediction algorithms. So like predicting affect from the parent and the child. Then using that to develop a triadic interaction study that kind of we changed the robot's role from providing a modeling role to the parent, so the parent can like learn what kind of questions that she or he can engage with their children, but also a robot making some of those suggestions for the parent and the child to have a conversation amongst them. And we've been so far analyzing the newly collected data on how the robot-mediated triadic interaction affects the conversation between the parent and the child. So let me first talk about the data set we collected. So we invited the parent and child pairs to the lab twice, and in between we sent a Lena device for them to record a portion of their daily conversation at home. So far we've used the lab collected data to analyze their verbal and nonverbal cues during the story time interaction. So this is a very extensive data set that the paper is currently under review, but it's a very extensive data set that includes the demographic profiles of the pair, but also the child's temperament and behavior questionnaire scale, the parenting style and parenting stress scale, as well as all the nonverbal cue extraction of, like, for example, their body pose, their gaze, their acoustic features, their affect, like human annotated arousal and valence level. And we are sharing these, and we have like 7 different camera views. So we're sharing all of that with this data set. On this data set, we also analyzed we ran some correlation study of how the nonverbal cues are correlated to these pairs like specific, parenting style, child's temperament, and also how their reading behavior, like for example, how many conversational turn take they have during story time, like who's reading and in what portion of the time, and things like that. And all of those analysis is in our data set paper. So I won't go to details on the analysis, but I'll show you some snippets of our data set. So we had 34 parent-child pairs, and we had in total 65 interaction sessions. So this is only the sessions that we conducted in the lab, which we have then the whole video data as well as along with the audio data. And these are the 7 views of the video and synchronized audio with the 7 video views.
Is following him? You think so?
I'll skip and show you some of the reading behavior that we analyzed. So we analyzed, they annotated for when the parent is speaking, when the parent is reading a book, when the child is reading a book, also when they're conversing.
I don't know. It doesn't look like Harry. Harry gave up and walked slowly toward the gate, but suddenly he stopped.
We also have annotations for the valence and arousal level of each parent and child.
People could watch the weather report.
And we also have, a tracking of the parent and the child, and also their body poses as well. And using this data set, we further conducted some algorithmic advancements. For example, this work was only using speech data, whether we could actually predict the arousal and valence level of the parent and the child. So here, what we did was we developed 3 models. Like first one is the baseline where we, so the difference between these 3 models is in the pooling layer that is highlighted with a green box. So the baseline model was just using a mean pooling, which calculates the mean value over time on the recurrent neural nets output. The right 2 tension, local tension augmented models use a weighted pooling layer that computes a weighted sum of the RNN. But I won't go into details about the approach, but we analyzed and ran a test with the collected data set that I just presented on. And we show that predicting the arousal level of the parent and child was significantly better than the baseline, but aligned with the prior literature. We also found out that predicting valence, though sometimes it worked decently, didn't work really well with just only speech data, which is motivating us more to work on multimodal data set. But this work was a quite good work in terms of its byproduct as well. So as a byproduct, we actually could develop a good diarization algorithm where we can understand when the portion of the child's speech and the portion of the parent's speech. So by predicting the arousal and valence, when their arousal and valence level is high, we could actually then understand when the child and the parent was speaking. So this was a really good byproduct in terms of advancing to our next set of works. So in this work, we implemented an agent that could support the parent and child's story time. So here, the motivation is that not all parents have equal access to resources of how to engage with their child and how to converse with their children, right? So in this body of work, we wanted to kind of really contemplate on what the role of the agent should be. And here we actually experimented with the robot's different roles. So there were 3 roles of the robot. The first role of the robot was just being there, having a presence, but as a bystander, the robot's job was mainly just observing the interaction between the parent and the child. And then the active role of the robot, we designed 2 models. So one is a model where the robot is directly asking question either to the child or the parent. So the idea there was the robot was trying to show examples of good questions that can be asked during story time, thereby we wanted the child to kind of get an idea of the types of questions and the way to kind of follow up with the child's response when they are interacting with children using a storybook. And then the most subtle role the robot took was making suggestions. So the agent made suggestion to the dyad to kind of discuss about certain topics, thereby just prompting them to engage and initiate their own conversation around the suggested topic. So we sent them a Jibo station. So this was during the pandemics just last year. So we had sent them a Jibo station as pictured here to every home. And then our students, so Willie and Sharifa, like logged in to the sessions and kind of watched over their sessions. And this study was a teleoperated study to determine when the correct time is to ask certain questions, but also to annotate at the same time of the interactions when the child is responding, the parent is speaking, and things like that. So in the end, this was also a pilot study, but at the same time, it was a data collection of a triadic interaction. So before going to the videos, I'll just go through our current plans of analysis and future work. So here, we actually just from running this study and just observing the interactions, we gained a lot of insight into how parents engage with their children. And especially when the parents' first language isn't English, we saw a lot of difference in their interaction strategy. So from this point on, we're trying to analyze this data on also making association to their demographic profile and survey profile to their actual behavior in engaging in the story time together. And the future work will be developing a personalized agent policy for each pair that the robot can provide. You know, for example, at the beginning, some parents might need more of robust direct question asking to get more examples of how to engage with their children. But then over time, the robot may increase more suggestions versus direct question asking, right? So we're trying to develop personalized policies on how to balance those robust roles based on specific child and parent pair.